Hi everyone, this is Tom from One Sightsolutions, and I'm going to introduce you now to our new series of videos called Techtalk. So we've been releasing various types of videos so far. So we've got our structured trading, like the 18-part Niagara Falls series we've done, and we've been supplementing that with various how-to videos since, of varying length and complexity. Now, the way a Techtalk video is going to differ from our how-to series is how-tos cover a specific task, and we show you how to perform that task click by click, step by step, explaining it as we go through. Techtalk is just going to be a general conversation or a general chat. I suppose you could think of it more like a presentation or a voice and video presentation, where we focus on an area of interest, and we just talk about it. We explain our thought process. Hopefully address any questions that you've asked yourself. I mean, this isn't going to be a direct Q&A session. It's a video, it can't be. But hopefully by us discussing a subject and applying and explaining our thought process, it might answer questions that you've asked yourself or have come through our support desk, for example. So that's what Techtalk is all about, and this is episode 1. Who am I? So my name's Tom. I'm the CTO of One Sightsolutions and IT infrastructure architect. I come from the mainstream IT industry, working in data centers and office space, campuses. My day-to-day work was designing networks, troubleshooting networks, building server infrastructure, particularly virtualization is a speciality of mine. But then I had an opportunity to move slightly sideways into this industry with OneSight about 7 years ago. And since then, I've been trying to help the business, help the industry along the way with the convergence that we're seeing into the standard IT world as well. Everyone should be able to see it quite clearly now, but with the IoT boom, the IoT revolution, and the smart buildings integration and everything, the building controls world market is on a path for convergence with mainstream IT, and as such, it becomes more and more important to have some sort of IT skill set on hand within businesses in this industry, to aid better integration and better service delivery. So let's move it on and go on to our episode 1 subject of choice, which is choosing a server for a Niagara Falls supervisor. So server-side applications versus desktop applications. Now, coming from the outside into this industry, I can answer that question quite clearly, especially through working in IT. And in IT, we have a very clear differentiation between what a server-side application might be or a desktop application might be. So a server-side application, for example, might be a web server, might be the Apache web server, might be Microsoft IIS. A server-side application might be an email server, Postfix, for example, Exchange. Could be a specialist app, could be a database that we're familiar with. But the important or common denominator between all server-side applications, or what all server-side applications share, is that they provide a service to connecting clients, and they are designed to provide it 24/7, 365 without interruption, if possible. So we can apply a Niagara supervisor to that and just ask ourselves, well, what actually does a Niagara supervisor provide? Well, it provides various services to machines and both humans. For example, the most common use case for it is a Niagara supervisor will amalgamate data and make it available via a set of graphical web pages to people that are web browsing to it. It can also provide alarming services via email, for example. And to machines, it provides a history archiving service, centralized scheduling, data collection. It can integrate from other data sources and pass them downstream, upstream, however way you want it. But the important thing to understand is it is providing services to people and machines, and therefore we would call it a server-side application. So let's compare that to your typical desktop applications. That might be Outlook, for example, on your PC, sending emails, web browsing with a web browser, using Office, creating documents, using, well, even Workbench, to be honest, is a desktop application. Niagara can be viewed, can sort of be split into two components. You've got your Supervisor, which sits there running a station, and it does so uninterrupted. But the Supervisor just happens to come with a Workbench application because that's what you need to configure it. But a Supervisor runs, and then you can connect to it with Workbench from a machine on the network. So a typical deployment would be the engineer's office or the control room in a big building has a few desktop PCs that the engineering staff can use. They have Workbench on them, and they may have screens up on the wall with web browsers that are showing the web pages served by the Supervisor. Could be plant graphics, historical data, trends, graphs, etc., anything. And then they could use the Workbench application installed on their PCs to connect to that running Supervisor station to perform any configuration or administration tasks they need to do. So there's the clear differentiator between what's a server-side application and what a desktop application is. And the Niagara Supervisor falls firmly onto the server side of that, whereas the Workbench part of it, which must be viewed separately, is a desktop application. So now that we've established that a Niagara Supervisor is playing the role of a server, it does a server's job. Why wouldn't you use a desktop PC? Well, you can see in front of me here that I've got a few bullet points, and there's no point on dwelling on them too much because I'd hope they'd be obvious. But a desktop PC, the hardware manufacturer, there's no hardware redundancy considerations. It's got a single power supply, it's unregistered memory. Usually no RAID, although some of them can have RAID. The OS it runs, the operating system it runs, let's choose the big one, Windows 10. It's a desktop OS. It's subject to aggressive update schedules. And since it's a desktop OS sat on the desk on your sat on a PC on your desk, you're likely to install other software onto it. Which may have an impact on something that's already running on it. Take, for example, if that is running a Supervisor station, you may download an app to do something, and then all of a sudden it causes the PC to crash, or it stops something's functioning. It's used day to day, and as I've said in the third bullet point there, it's typically installed in an environment where it's likely to be used as a PC by someone. So you've got this application on here, the Niagara Supervisor, which is installed and running, doing a specific job. However, if it's on a desktop PC, that is not that piece of equipment's sole purpose. It's likely to be used for other tasks as well, which may have a negative impact on running the Supervisor itself. So that in a nutshell is your three primary reasons why you don't use a desktop PC to do a server's job. Right. So the next point I've got to cover on my list here is where to go shopping or where to look. This is a relatively easy one, but it is very, very easy to get hold of a desktop PC, and immediately and quickly as well. I mean, if you need one in a hurry, you just go down to your local Currys in your PC world. You can probably even get them from some major supermarkets. So if you need a piece of equipment that will run a Niagara Supervisor in a hurry, I can see why a PC is a tempting choice, but it's not a choice in favour of longevity and continuity. So where do we obtain a server? Well, there's a few places, well, there's hundreds of places where you can get hold of them. But if we jump over to the web browser here, the Dell website, so Dell directly, is a good place to start with their PowerEdge range. Or the HP website is another good place to start with their Proliant range. There's various outlets, guys, and I'll let you look on your own. But HP and Dell you generally can't go wrong with, as they're the two biggest manufacturers in the world. So now that you know where to look and you know the reasons why we'd choose a server over a desktop PC, we can look at the specific hardware considerations. Now this is quite an interesting one, where I see specifications come into one site for big projects. Some of the hardware recommendations and specifications that I see on these specs, I have absolutely no idea really where some of those choices have been made or why they've been made. I say I don't have an idea. I have an idea, but perhaps the person that chose those pieces of hardware or recommended those pieces of hardware might not quite understand what each area provides as well as someone like myself does. So if at first a main part or piece of hardware that makes a PC or a server is the processor. We're in an age now where nearly every x86 architecture processor is extremely powerful and more than capable of running a fast Niagara or Supervisor system. But a general consideration here is a single quad-core processor at 2 GHz upwards is adequate for even the biggest Supervisor I've ever seen, with hundreds of traces and tens of thousands of data points. So that's not a difficult one. What I would say is, but this goes back again to desktops, avoid your low-range, cheap processors that you'd find in desktop machines. But you usually won't be able to find them in a server anyway, because we move up to a higher caliber of hardware. So a processor such as a Xeon E3, Xeon E5, E7, their current ranges, silver, gold, and I think bronze nowadays. But a quad-core Xeon processor is a good place to start, 2 GHz and upwards. And obviously you can go big with your processor. You can have 2-4 processors in a server depending on the size. I think quad core is probably the lowest core count you will find now. There's 8, 12, 16, 18 core processors available, and you can have multiple in a single chassis. But there's a consideration on software licensing to take into account here. And it's important that you don't go silly just because budget allows, perhaps. And that is that Windows Server licensing in particular is on a per core model now. So let's say a quad-core Xeon processor that's more than capable of running a huge Niagara system with tens of thousands of points is available. You could choose that, but instead you go and choose a pair of 18-core processors. Well, all of a sudden, on per-core licensing, you've now got to pay 4, 6, 8, 12, 16. You've got to pay 5, 6, 7 times your licensing cost. And your Niagara Supervisor will not benefit from that quantity of cores. So although I'm all in favour of everyone going for mega powerful servers with really expensive and really feature rich equipment, I also am completely aware of costs that creep up on you with software licensing and things like that, and you don't need to go over the top. So yeah, anything like a quad-core Xeon at 2 GHz and up. If you're buying new, it's going to be recent anyway, but generally anything in the past 5 to 6 years is more than capable of handling the biggest supervisor you'll ever see. So moving on to memory or RAM. Memory is relatively cheap in this day and age. 8 gig, I'd say, is the absolute minimum I would want to see on a desktop computer. But 16, 32, 64, 128, 256, 512 gigs of memory is not uncommon in servers. and I would use on a server that's doing a supervisor and a supervisor alone. I would choose 16 gig as a minimum now. So far we've got a quad-core Xeon processor and 16 gigs of memory. Now, power supplies, depending on the chassis or the form factor of the server you're choosing, you're going to have options here as well. So you can have a single power supply. Obviously that provides no redundancy. You can have dual power supplies. Some servers or bigger chassis go even more than that, but the idea there is you provide power supply redundancy in an active configuration. So in the event that one power supply fails, the server will still function. And for some reason I just jumped over disks and RAID there, but I'll come back to that now. Disks and RAID, another misunderstood area, should I say? And we're in the age of SSDs now, so solid state disks replacing magnetic spinning disks. The only compromise that you're making there is a cost and space one, because a 1 terabyte SSD, well, an enterprise grade one at least, is going to be times and times and times again more expensive than an equivalent 1 terabyte spinning disk. But that is how it is. It's in the whole history of computing, we're still in the early days, the infancy of SSDs, even though they've been around a good 10 years now. The biggest thing to mention with an SSD though is the performance it gives you over the spinning disk is absolutely huge. It is the single most beneficial thing you can do, or the single most effective thing you can do to a machine, a computer, server or desktop, to increase its performance. SSDs do have a limited life, a limited write cycle, i.e. the flash memory on it. However, this is usually measured on a good quality enterprise class drive in hundreds of terabytes right before the flash rating is reached or it wears out. So I suppose one thing you can account for is that you do have a more predictable failure rate with solid state storage, so to speak, because it's got a limited write cycles or a rated life cycle. Whereas a spinning disk, it's got several moving parts in it. It's a mechanical thing. You can experience unexpected breakdown, and for anyone that's worked in the IT industry, disk failures are common. In fact, they are by far the most common piece of hardware that fails, probably in the world, out of any sector apart from automotive, really. Hard drive failures are probably the single most common piece of mechanical equipment that fails in the world. But anyway, rounding that up, just on disks alone, I would recommend SSDs in this day and age over spinning disks. However, there is a space and a cost trade-off against that. While we're on the subject of space, let's talk about realistic expectations and usage of disk space on a Niagara supervisor. Having terabytes and terabytes and terabytes of space at your disposal may sound attractive or look good on a specification or in paper, but in fact it's a complete waste of space. You would be much better putting your money into a performance component like an SSD as opposed to a capacity-based component like large spinning disks. In our experience, we've got several sites with 50,000 points. Histories every 15 minutes, and even going back with 7 years worth of data across, say, 50,000 points, we're not even talking 30 gigabytes of data on the station. It's really efficient, or really quite something when you think about it, because you do expect it to be a lot more. But as long as the database technology, which is storing that information, in this case it's a Niagara history database, a standard, with white space compression, things like that, all you're doing is storing a few characters, if you think about it, a few bytes here and there for each history record. So having tens of terabytes or whatever is unnecessary. When even our biggest systems we deal with upwards of 40,000 points, would easily fit onto the average size hard drive that was mainstream 15 years ago. So bear that in mind. I would prioritize performance over disk space, because disk space is not a concern as far as we've ever seen it. So in combination with disks, let's talk about RAID. A popular subject, but misunderstood as well. There's various different RAID levels, and you have to remember at this point that RAID came about from an era where we were using relatively small-sized spinning disks. It's designed to do two things. RAID can increase performance. Three things. It can increase performance, it can increase space in a single logical drive, and it can increase your redundancy. It could do a combination of some of those things as well. But let's go over the common ones. I do know these off the top of my head, but I do have a thing over here for you to look at as well. I would suggest Googling it if you don't understand it already. But you've got RAID 0, which is a stripe across two disks. So it effectively doubles your performance, doubles your space in your single logical drive. However, at the risk of, if you lose one of those drives, you're going to lose everything. Not recommended. Full stop. RAID 1 is a mirror of two disks. So you'll have the performance of just a single disk. Data is replicated in real time to the second disk. So all this does is provide redundancy in the case that one drive can fail. You can still operate the application or machine that the data was stored on those disks. This is really effective nowadays, actually, with SSDs, because the reason in the spinning disk era why I wouldn't have recommended RAID 1 is because you're not going to see any performance benefits. All you're going to do is give yourself some redundancy. But because we have SSDs now, and a single high quality solid state drive could provide the performance of tens of 15k RPM SAS disks previously, it's actually very cost effective and a really solid and well performing setup to have a pair of SSDs in RAID 1. RAID 4, I wouldn't say it's that popular, to be honest. I've certainly had no cases where I've ever had to use it. RAID 5 is a trade-off between performance benefits offered through striping, i.e. RAID 0, and some of the redundancy benefits offered by RAID 1. But as opposed to straight mirroring that RAID 1 uses, RAID 5 is parity-based, where it distributes parity information across each disk in the array, which it can then use to rebuild the data from a lost disk should it need to. You do take quite a write penalty when you use RAID 5, as it's got to also duplicate the data across other disks, the parity information. But RAID 5 is generally quite popular, but I'd arguably say in the age of SSDs now, it's probably unnecessary. RAID 6 is the same as RAID 5, but double parity. RAID 10, my personal favourite, especially when using spinning disks or large arrays of SSDs, if you feel the need to, is a combination of RAID 1 and 0. So you have a pair of mirrors, so effectively a pair of RAID 1s, and they are striped, so you get redundancy through data duplication, and a stripe, so you get the performance of both those sets of disks working in tandem. The trade-off with RAID 10 is that you lose, I think it's about 50% of your capacity. But this is usually my favoured setup, because you trade off space, but if space isn't too important, you get the benefits of a RAID 0 performance setup with the benefits of a RAID 1 redundancy setup. There are others, 50 and 60 for example, but there's no point in us going over them at this point, and I'd probably say in a single server Niagara Supervisor deployment, it's not something you'd need to look at. So jumping back to our document here, disks and RAID. At this point in time, if you have the budget to use SSDs, I would recommend a pair of small to medium sized SSDs, 256 gig, 512 gig, something like that, and you use them in RAID 1. Make sure you're going with enterprise grade SSDs from the hardware manufacturer, because they offer much longer write cycle guarantees than your typical typical consumer grade SSDs. If you wanted to double up on your setup and go a bit faster, provide some more redundancy, for example, you could go for RAID 10 instead. But like I said, the performance you get from a single SSD is mind blowing compared to what you used to get from a single spinning disk. Even a group of spinning disks, the IOPS, input output operations per second, you can pull from an SSD is groundbreaking. So a pair of SSDs in RAID 1 is a perfectly adequate, more than adequate option. If you have to go for spinning disks, I'd recommend at least a quantity of 4, preferably 6, and use a RAID 10. This will give you a great balance of speed, performance, and redundancy in one package. But like I said, go SSDs if you can. If not, go for a RAID 10 and 4 or more spinning disks. Last one is form factor as a hardware consideration. Rack versus tower. That's a personal choice based on the environment it's been installed in. Is it going in a rack? Yep, then get a rack mount server. If not, then get a tower server. There's one I've missed off this list, and it's networking. Just had that on there. This is again going to be dependent on the network environment that your server is going to be installed onto. 1 gig is common, and most new servers will have at least 2 1 gig RJ45 copper network interfaces. 10 gig is getting extremely common now. But bear in mind what your network connectivity situation is like. You can provide network redundancy as well into your network if you're using managed switches. You could run it's Ether channel in a Cisco world, or a bond LACP, so a pair of 1 gig links, for example, to your managed network environment, and provide a bit of network redundancy there as well. So that's about as much as I can waffle on about hardware considerations for servers, guys. Rounding up, processor, quad-core Xeon, 2 gigahertz and above, anything from the past 5 or 6 years is going to be more than adequate. RAM memory, you want to be working to a minimum of 16 gig in this day and age. Memory is cheap. There is absolutely no reason to constrain yourself on memory. Disks and RAID, this is the age of solid state storage. It's much faster than spinning disks. So a simple 2 SSD RAID 1 setup is more than adequate for a Niagara Supervisor, and you get your redundancy and you get your performance. Disk space is nowhere near as much concern as people may think it is with a Niagara Supervisor. You'll have more than enough storage space for tens of thousands of points going back 10 years, even with 250 gigs. So don't worry about going multi-terabyte there. Of course, if you want to run like a backup array and you're retaining your backups forever, you could kit the server out with some big spinning disks as well and just store backups forever on there. But that's a case-by-case decision. Power supplies, 1 or 2, up to you. 2 always recommended for redundancy. Rack versus tower, environment preference again, and networking. You can cover any scenario based on your specific deployment, but having a server with more than one network interface provides the option of using technology like LACP to create a bond and provide network redundancy. So the next thing we move on to is operating system considerations. See the first item on my list here, Windows Desktop OS, much more aggressive update schedule. So that's just glancing back to the fact that a desktop PC will have a Windows Desktop OS on it, like Windows 10 for example. Comes with plenty of bloatware, plenty of apps you don't need, and an aggressive update schedule. but that's fine. We don't install them on servers, and we've learnt that using a desktop PC to do a server's job is a bad idea for the reasons we've already mentioned. So how does a server operating system differ from Windows 10? Because to a lot of people, Windows is just Windows. And again, this comes to reliability / redundancy. A server operating system is designed to run 24/7, 365. Its configuration generally will not change unless it is changed by someone else. You're not gonna get some intrusive application randomly installed. You're not gonna subject yourself to forced restart updates. And because it's usually not sat on a desk with a keyboard, mouse, and a screen plugged into it, no one's going to go onto it and start using it to browse the internet. So the other thing I forgot to mention here is the fact that a server operating system is usually modular. In the case of Windows Server, you install it, and by itself it operates in a fairly similar fashion to Windows 10, for example, on a desktop PC, apart from it doesn't look as shiny. It won't really do much for you until you start installing some applications. And in the case of Windows Server, those applications which you can make Windows Server do out of the box are known as roles and features. So one of them might be a DHCP server. You can have a DNS server. You can make Windows Server a domain controller running Active Directory, a print server, a file server, a certificate services server. Probably mentioned IIS web server. You can make Windows Server perform a whole host of different roles without installing any third-party applications. But out of box, it comes slimmed down to the core. You can even install it without a graphical user interface if you want, with the core versions. But unless you are an experienced Windows admin, I don't recommend it. And I'm not even sure that the Tridium advertised compatibility with Windows Server Core. So Windows Server is geared to be a much better operating system for a Niagara supervisor that's just going to be doing one job its whole life. It doesn't need to do anything else, and therefore it doesn't need to have anything else running or installed on it. Of course, you have the option now of running 64-bit Niagara on Linux. Red Hat Enterprise Linux 7.5, I believe, is the supported one for Niagara 4.8. From experience and knowledge, I can tell you that CentOS is an identical clone of Red Hat, and Niagara also runs on that. But Red Hat comes at a cost, but that cost gets you enterprise support. That there's something to be said for enterprise support, but again, it's a balance between how much money you want to spend on being supported versus how much knowledge and how confident you are in-house in looking after that should something go wrong. Let's just take a look at this technical document from the Niagara community, which is supported operating systems and relational database servers for Niagara installations. I'll see here under Niagara 4.8, Red Hat Enterprise Linux 7.5 is a yes. We've got some desktop OSs here, which we're just going to ignore. Server 2003, yeah, pretty old. And Server 2008, also really old now. 2012, this is a popular install choice because customer IT departments usually turn over, update, or operate at a much slower rate than a smaller, more flexible business. So you'll probably come across 2012 R2 as a standard build if you're installing to a customer's managed environment a lot. But it's important that you note here that Tridium are not advertising support for Server 2012 R2 anymore as of 4.8. However, Server 2016 and Windows Server 2019 are. So there are your options for Niagara 4.8, Windows Server 2016, Windows Server 2019, or Red Hat Enterprise Linux 7.5 or CentOS 7.5, although it's not on this list. So let's just skip back to this. So I think that's just about all I can waffle on about, guys and girls, with regards to how you choose a server for Niagara. I know I had a bit of a moan about people using desktop PCs, but that's a moan from a perspective of an IT guy looking into this industry, and understanding that you use a server to do a server's job and a desktop PC to do a desktop PC's job. Yes, you will make a significant cost saving by providing a low-cost desktop PC. However, you set yourself up for potential problems going down the line. Not that you guarantee any problems, but you are leaving yourself open and making them more likely to happen. And if an IT guy like me was employed by that client, came along, and you've provided a low-cost Windows 10 machine to serve as the head end for their massive, shiny, new, expensive control system, I don't know what I'm going to do. I think I'm going to fall over, faint, die, whatever. So we use servers to do servers' jobs, and we use desktop PCs to do desktop PCs' jobs. Under suggested specs, my last point on here, I know I've already said this a couple of times, I think, but there is a set of hardware requirements on the Niagara 4 Supervisor datasheets. They are here. Xeon CPU, dual or quad compatible. It's got your operating system compatibility, memory requirements, hard drive, etc. If I had to pin some numbers on it like I already have, I'd say a quad-core Xeon processor above 2 GHz. Anything in the last 5-6 years is more than adequate. RAM, don't skimp on this, 16 gig or upwards. Disks and RAID. The most effective thing to do at the moment is a pair of SSDs in RAID 1. However, if you are going spinning disks or you want to use more SSDs, look at a RAID 10 setup. That gives you the best benefit, the best balance between performance and redundancy. Power supplies, 1 or 2, your choice. Recommend 2. Rack versus tower, that's environment specific. And networking, if you've got the network environment for it, i.e. a managed network environment with managed switches, give yourself a pair of at least 1 gig network interfaces as well that you can run link aggregation across to give yourself some network redundancy. Anyway, guys, this rounds up our first Tech Talk, episode 1. Choosing a server for Niagara 4. I hope it's shine some light on the subject, and hopefully when we come along with episode 2, might do something a little bit more engaging on the video front, rather than just making you stare at this Word document and web page for the last 40 odd minutes. Anyway, guys, that's me signing out. Thank you. Please like and subscribe if you want to see more like this. Bye.